Hey, welcome to the Pendulum experiment. This is the first lab that we are doing to introduce our general lab process. And you're watching this video because you were absent from class during that time when we took the data. So I want to walk you through what we did to collect that data and what the general lab process will look like. All right, so I don't know if you can see it, but behind me there is a pendulum hanging from the document camera or the projector, and we ran through this question. So we always introduce one of these like kind of fundamental patterns experiments with a wild guess. How long would it take to complete one swing from 60 degrees there and back? That is the wild guess question. And obviously we could just take that data right now. You could come up with a number and then we could just do that. But that's not science, that's just guess and check. Okay, so you're going to write your wild guess for that at the top of your paper, right? Wild guess and then how long you think it'll take in seconds. In order for us to come to a better understanding and to make like an actually informed prediction, we're going to run through some science. And the way that we will do this, and we do this kind of the same for all of our different experiments, is we start off with our wild guess and then we do science, right? So we like run an investigation and we collect data to figure out a pattern. Oops. And then we will through analysis or through discussion, we're going to make sense of that, and we're going to come up with kind of a rule. And that's also our conclusion. And then we're able to circle back and make a data-informed prediction, a better prediction that is hopefully closer to the real answer. And we'll show how we used science to make better predictions. Okay, so what we're going to be doing is we're going to be changing one thing and measuring something else. And in this one, I'll just give it to you. Our independent variable, what we're changing is the starting angle. So I will be changing the angle at which I'm releasing the pendulum, and then we are measuring the time that it takes for it to complete one full swing there and back. In science, we call that time of one swing the period of the pendulum. Doesn't matter though, we'll just call it the time of one swing. So that's our dependent variable. We'll be using timers for that. Okay, before we get started, let me move myself over here. We're going to make a hypothesis, a prediction. And so this is related to the research question. How does the angle of release affect the time of one swing? Now, it's probably easier to do this in words. You'll start off by writing, I think that as the starting angle increases, okay, as we get, higher and higher, the time of one swing will, and you're going to write in increase, decrease, or stay the same. And then you're going to make a graph of it. And this is a graph of starting angle versus time of swing. And what I'm really checking here is, are you able to make a graph that matches what you say in words? Do you understand? Do you have an idea of what the data is going to look like once we've collected it? So if you think that it's going to increase, that the time of one swing will increase, what would that look like as a graph? If you think that the time will decrease when we increase the starting angle, what kind of graph would that look like? How would you draw that line? Or if you think that the time is going to stay the same as the starting angle changes, as it increases, what would that look like? So I'm just looking, especially for your hypothesis, it's not about whether or not your hypothesis ends up being correct. It's about, are you able to match a graph with words and put those together? So you'll give it a try for this one. All right, we're going to collect data, observations. We're going to collect our data on the computer. It's a little bit different, but it's a really good way of grabbing everybody's data and putting it all together. So I'll show you how we're going to do that. You're going to find your class, and you will click on your class to get to the data collection. All right. By the time that you're viewing this, you will see other people's names populating right here, and you're just going to find one of these that's open, and you'll write your own name in here. You can also see other people's time of 3 swings. We measured 3 swings because it's easier to track time for 3 than it is for just 1 swing. And this data table is coded. I'm just going to throw in like a random number here. So let's say that it took 4 seconds here. Cool. And let's say that this person measured it as 4.3 seconds. There we go. So it's coded so that it will tell us what the range of the data set is, as in like the difference between the person who recorded the fastest time and the person who recorded the slowest time for the same event. And then it averages out all of the data that's going to be in this row here. And then it divides that number by 3 in order to find the average. So it's telling us the average time for one swing, going back and forth, for a 10-degree angle would be 1.4, according to this time that I've thrown up there, and that's, yeah. You can see from your class data whether that's similar or different. So what you're going to do is I'd like for you to add your own data to this. We're going to go ahead and take some data right now. Okay, so 10 degrees, ready, set, go. 1, 2, 3. Okay. Stop. If you need to redo that, just return to the video. Let's go to 20. Ready, set, go. 1, 2, 3. 30 degrees, ready, set, go. 1, 2, 3. 40 degrees, ready, set, go. 1, 2, 3. And last 50 degrees, ready, set, go. 1, 2, 3. Okay, so you have collected your data. Now you'll be able to graph that data in Desmos, and there's a video to help you out with that if you're not familiar with Desmos. And you should be able to start establishing what kind of pattern this would be and make a data-informed prediction for 60 degrees.